As you can see, this setup is actually very simple. So if we look at the graph of this solar data logger, we can see something interesting happen.
Tanner. Hello, this is Tanner Tech.
Almost everybody has heard of the Great American Solar Eclipse of 2017. This is this one rare time where the moon passes directly in between the sun and the earth, casting a shadow, and letting us see what the shadow of the moon looks like. It's really cool. Everything also gets darker too because half the sunlight is actually blocked. Now, a lot of people are just using these glasses and stuff to see the solar eclipse, but I wanted to graph the solar intensity throughout the entire eclipse because that sounded pretty cool to do. And so I built this little Arduino device. Now what this does is it has a solar panel on it. And when light hits a solar panel, it excites the electrons inside it and causes a current to flow. And this current is maximum about 3 volts. Now what happens is when this voltage is across these 2 pins of the solar panel, it is able to be read by the arduino, the analog to digital converter. And that means we can have a very detailed reading of what the voltage of this solar panel is. As you can see, this setup is actually very simple. It consists of this little tiny solar panel thing right here. Now what this is it is a little row of header pins, and the solar panel is soldered onto one of the header pins via this little metal rod. That's the ground. It is also soldered to positive or analog pin 1 and ground with these 2 wires on here. It can then be placed inside these little pins right here. So it goes to ground and analog pin 1. Now this is an SD card shield right here that just mounts onto the back of the Arduino. And it has this little micro SD card inside it that allows me to record all the data that is stored by the solar panel. So this is the Arduino program right here that is actually on that data logger. Now I kind of stole most of this Arduino program from the Arduino website because it has a tutorial on SD cards. But pretty much what it does is it initializes everything inside the SD card and sets all the pins and does all that stuff. And then it does this thing right here, which pretty much initializes the SD card. And if it's not plugged in, then it'll send an error. And then it will also make this data string right here. Now what happens is the sensor is set to the analog read. Now that's the raw data value from the analog to digital converter. And what that'll put out is a value between 0 and 243 or 223 or something. And that value is immediately written to sensor, and then that is added to the data string through a plus equals function. Then down here, it is actually printed to serial print, and it's printed to data file. Now data file is what the SD card is, and when it is printed there, then it saves it to the data file. And it's somewhere down here, but I guess it's right here actually. File times data save. That actually saves the data log to the SD card. So that's how the Arduino works. Alright, so now that you know how this little Arduino data logger works, let's go set it on a roof somewhere where we'll have full sunlight, and we can leave it for a while. By the way, it'll be plugged into a power source via an extension cord and a little USB power supply. So this right here is my data logger. What this data logger is doing right now is it is recording the voltage put out by the solar panel during the solar eclipse. And this voltage should tell us the sun's intensity. Alright, so now that we have this data logger on the roof collecting data, let's go take a look at what the solar eclipse actually looked like through one of my kind of homemade devices using a telescope to see the eclipse happening. The sun is entering this telescope through this aperture. It's bouncing off the mirror in the back and off a little mirror in here and getting focused by this little eyepiece and being projected onto this piece of paper. That was pretty cool, but you may have noticed that the actual eclipse didn't go complete. It didn't have that black dot with the line around it. Now the reason behind that is I live in Southern California, and that is an area where we only get a partial eclipse, which isn't as cool as the total eclipse, but it's still pretty cool. Now, it's time to analyze the data. Okay, so now after you take the SD card out of your solar data logger, after the entire eclipse is done, you should have all these numbers saved in a notepad thing called data log. Now this was just on the SD card that was inserted into the Arduino, and it has all these numbers. And it's kind of hard to make sense of all these numbers when they're just like this, because you can't see them as a bigger picture. So what I've done is I've taken an Excel spreadsheet, or a Google Docs one, and I've inputted all these numbers, and I just copied and pasted them straight from the notepad. And then I made numbers on the side, just ranging from 1 to about 400 and something, because there's 400 and something data points. So if we look at the graph of this solar data logger, we can see something interesting happen. The trend line starts going down, and this is when the peak of the eclipse happens. I can verify this because the eclipse logger was taking a reading every 30 seconds. And so at about 150 is 1021 when the eclipse reached its full maximum for us here in California. So the eclipse, or the sun intensity, goes down here, and then as soon as the eclipse finishes up and starts going back, you can see that it goes up. So this first part of the eclipse kind of makes sense. But then something interesting happens, and the solar intensity drops right here. And now I'm not exactly sure why this is happening, but if you look at this picture, which shows a different graph of solar intensity that someone else made, you can see that it comes up here, and then it dips, and this is for a total eclipse, but ours isn't a total eclipse. So it'll go about here, which is similar to my graph, and it'll come back up here and drop again, which is kind of similar to what happens in my graph, where it comes back up and it drops again. So if we assume that this graph has a curve that goes like this, we can see how that's similar to this graph. So that may explain it. Also, the solar panel may have heated up after this, and that heating up of the solar panel may have caused something to happen with its resistance or something, and it made the voltage drop. Anyhow, this is the pretty cool graph that was the result of this whole data logging exercise, and it's actually pretty cool to see. I hope you guys enjoyed that cool little experiment with this little Arduino data logger, and I hope you guys enjoyed that awesome solar eclipse. As always, thanks for watching, and stay tuned for next time.